Hi, my name is Roman and I'm going to present you our new framework BF-CBOM. With the rise of quantum computers, it is well known that large parts of classical cryptography used in software these days is rendered insecure. That's why software engineers are sooner or later forced to identify these assets and decide whether or not to migrate them towards quantum secure alternatives. For that purpose, several CBOM generator tools have emerged, which identify these assets and report them in a standardized manner in so-called Cryptography Bill of Materials, which is a similar concept than Software Bill of Materials, so-called SBOMs. Now with BF-CBOM, you can actually do this at a larger scale. You can orchestrate several CBOM generator tools and then collect their outputs and comparatively analyze them in a unified layer. So for this demonstration, I will demonstrate you this three-step workflow to inspect the cryptographic posture of a given source code. For a start, we create a new inspection, give it a name, and we can choose which workers should be included in this inspection. With workers, we mean actually dedicated CBOM generation strategies. As of now, we have integrated three different for-purpose CBOM generators and also an alternative fourth strategy that uses an LLM. We could do an individual inspection, but for the demonstration I will go for the batch inspection by pasting a list of interesting GitHub repositories, create this batch inspection. Now BF-CBOM will pull some meta information and we are ready to go to the next step, which is the execution. So the second step of the workflow concerns the actual execution. We can start this new batch inspection, which will then let BF-CBOM to trigger individual CBOM generation jobs to all of these included CBOM generators. They will then generate the CBOM following their own strategy and provide, upon completion, the standardized CBOM file back to the BF-CBOM, which collects them. We can immediately see, for instance, here in the DeepSeek strategy, how long it took to generate the CBOM and actually what is the file size of the resulting CBOM. I will fast forward this process. Okay, with the execution completed, we can now move to the third step of this workflow, which is the analysis. On the analysis page, we first of all see some descriptive statistics about the job status summary, how many jobs failed or timed out, for instance. Then we also see how long it took for each worker to generate a CBOM per repository. For instance, shown in the x-axis over the different repository sizes, which we could also swap on the different amounts of reported components. And here we see immediately that there is apparently one CBOM generator tool that is quite over-motivating in finding components and reporting them in the CBOM. So we could remove the CDXGen to have a more meaningful view on that. Now, this is also then again provided as a table, just with distinct values, but the actual most meaningful part here is at the bottom, due to two reasons. First of all, we see for each repository a unified, distinct set of cryptographic assets that have been reported by all these different CBOM generator tools, right? So for instance here, a cryptographic asset called HMAC-SHA, declared as algorithm, was reported by ZDXGen one time. And similarly, we also have another HMAC-SHA 256, so lexically differently written, which was reported by CBOMKit one time. Now, luckily, BF-CBOM allows to detect these similar components automatically thanks to our n-way matching algorithm, which is specified in the paper. So we see, for instance, here the match that BF-CBOM has declared these two components, HMAC-SHA from ZDXGen and this HMAC-SHA 256 from CBOMKit, as the actual similar component. Now what we see here are the relevant sections from the original CBOM. And we can learn from it that CDXGen actually does not disclose as much meta information as CBOM-Kit. So CBOM-Kit actually declares the exact location in the source code that has provoked it to report on this cryptographic asset. So we can check this by copying this path, going back to the GitHub repository, search for it. I think it was line 65 specified. Indeed, here we have the HMAC SHA-256 algorithm. So further features of our BF-CBOM includes the download of all raw CBOM files from a given inspection. And this would then allow to have a closer look at it or analyze it with other tools or also just archive them. Besides this, BF-CBOM also comes with a command line interface to facilitate programmatic access. For instance, monitoring progress of running inspections, but also triggering new inspections based off, for instance, pre-exported configuration files. So with our BF-CBOM framework, we contribute a fundamental tool to the Cryptography Bill of Materials domain. For example, practitioners can integrate it into testing and deployment pipelines and therewith much better comprehend the current cryptographic posture of their software. But also CBOM generator vendors can use BF-CBOM in order to comparatively analyze their performance of their tools with others. And also security researchers can leverage BF-CBOM to streamline large-scale studies on the maturity of such CBOM generators. This brings me to the end of my demonstration. I would be very happy to receive your feedback. You also find much more information and all the source code on our GitHub repository page. Thank you very much for your attention.